I teach digital signal processing to seniors and graduate students at the University of Minnesota. What is digital signal processing? Let me give you an example. A pacemaker uses signal processing to detect abnormalities in an electrocardiogram or ECG from the heart in order to deliver a shock when needed. The most exciting thing about DSP or digital signal processing is it's such a powerful technology that can be used everywhere. If you are storing your images from a camera in JPEG format, that saves 10 times the number of bits or 50 times the number of bits compared to a bitmapped image. If you are watching TV, the TV station is sending an encoded version that is decoded at the TV, in the receiver in the TV. So DSP is key to all technologies, whether it is a cell phone or telephone lines or transmitting hundreds of gigabytes of data through fiber cables that go underneath the oceans. And again, transmitting data at those rates requires a lot of signal processing. This important technology is used everywhere in applications such as wired and wireless communication systems, storage, coding and decoding, speech, audio, image, and video processing. It is an integral part of modems, TVs, and cameras. Other examples include predicting earthquakes from seismic signals and in analyzing biomedical signals and images. My class involves a lot of math, and it's easy for students to lose sight of these real-world applications. In a typical digital signal processing class, the professor writes equations from one end of the board to the other, and students spend class time copying notes. They do not typically work on programming assignments that would help them understand how the math relates to the processing of signals. Like many engineering professors, I used to write down a lot of equations on the board or flip through PowerPoint slides and pause to ask if there were questions. But I changed my teaching style because I want my students to relate math to real-world applications. Starting in fall 2013, I moved my class to an active learning classroom. Now I set aside 15 minutes for every class for students to work in groups. Students work in groups of 2 or 3 to solve problems or take a quiz. They also work on MATLAB experiments as part of group activity or quiz. I also changed how I deliver content. I distribute PowerPoint slides of my lecture before the class. During the class, I use PowerPoint slides to quickly go through easy concepts. However, I take the time to explain more difficult concepts by writing down every step on paper under a camera that was displayed to the entire class. I also run MATLAB code in class to demonstrate filtering of audio sounds. This approach has freed up extra time for group work. My students reacted positively to my demonstrating the experiments. It got them engaged. It really helped them understand the implications of the math that they were seeing through these experiments. This approach to delivering content and having students work together and share their results help students develop intuitive insight into signal processing.